Awesome. Yeah, we can start from here. Hi, everyone. This is Chris from Throw Hacks. I'll be the host for today's workshop. As you can see, today's workshop is from with Hackathon 2022 to 2023. And today's speaker is Bram, which is the SC developers. And today's topic is about how to creating an NFT mint dApp on Waves blockchain. So Wave Hackathon has ended for a while, but we are continue doing workshop with Wave teams and Wave ecosystems, basically to better create educational content for developers who are interested to learning more about Waves and how to developing on based on Waves technology, because they have a very unique coding language compared with other more wide-use one like Solidity or Rust. So if you are very interested in Waves, if you want to learn more about it, definitely this workshop is going to be super useful for you. And we also have a series of the similar workshops before. So if you want to review those, please go to our YouTube channels as well. We have all of the recording there. And before we officially start, keep in mind that if you have any questions during Bram do his workshop, please feel free to ask in our YouTube or Binance Live chat room. In the end of the workshop, we will ask those questions for you guys. So sounds good. Bram, I think it's your time. Feel free to start when you're ready.
Okay, so one of the first workshops was basically Vladimir building an NFT marketplace, so you could buy and sell NFTs. With that idea in our head, we are today going to create a dApp that basically can mint NFTs. It will store some information on the blockchain, some metadata. It will have an IPFS link and all that kind of stuff. So what did I do as preparations? I uploaded already an image to IPFS. So our NFT will contain following image. So as you can see, it will be an image for me just for demo purposes. And what will be important for us is the hash that we will be using to create the NFT. So first, we have to start with creating our basic method. So we want to create a mint NFT dApp. So basically, we start with creating a callable. Callables are methods that can be called and can be basically invoked. So they aren't internal. So they can be invoked by users or by external dApps. So we start with a callable. We call it something like mint NFT or something like that. And we create our basic method. So we always need to return something. The square brackets is basically what we are going to return from this callable function. So now we need to think what is important for NFT. There are different aspects that we probably want to store with the NFT, and one of them is, of course, the hash that we're going to store. So we create a parameter in our function called IPFS image hash, and it will be of the type string. So now we will be able to call this callable with one parameter, the hash. So now we need to think, what will we do with the hash? We, of course, want to store it on the blockchain together with the NFT that we are going to mint. We can mint an NFT by the smart contract to create basically an asset asset issue. So we are going to define a variable, let variable, and we are going to say we want to issue. Then we will see that our method has a need of different parameters, a name, a description, quantity, decimals, and is reachable. Since we are going to create an NFT, we don't want decimals, we don't want it to be reissuable, and we only want one item from this NFT. Otherwise, it won't be an NFT anymore. So we are just going to pick a name. So for the hack purpose, we are just going to call it Dora NFT, something like that. For now, the description, we can do something hard-coded first NFT. We will later adopt it, but we will do everything in phases. For the quantity, we of course say we want only one. Decimals we don't want, and we also don't want it reachable. You can now see that it basically is happy the code could be compiling. Of course, this isn't going to do a lot yet, since we don't execute it yet. So if we want to make sure that the issue will happen, we need to give it back as the result. So we are already going to put the asset in the result list. So now the asset will be minted. Of course, we want to connect some data with the NFT. Now, how do we connect data with the NFT? One of the first things we need is the unique identifier, or the asset ID, basically. So how can we get that? There is a built-in function for this one. So if we would go, we can see asset, and the function is calculate asset ID. This will give us back, if we look on it, it will give us back a byte factor. But to store data in the data transactions, basically, it's sometimes, if we want to store it as a key, it needs to be a string. And it's also more readable if it is a string. So we are just going to convert this to string. Okay, so now we have calculated to base 58 string. Why is it to base 58 string? Because basically it's a byte factor with base 58. So we want to convert it. So now we have the asset ID. Since we now have the asset ID, we could store some data connected with the asset ID. So we mint the asset, and let's say we now want to store our EPFS image with the asset ID. So we say we want a string entry. So we are going to store a key with a value, and the value will be type of string. So what will we be storing? For example, we can store asset ID. We need to make sure the key is always unique, of course, otherwise we would be overwriting it. And then underscore EPFS or something like that. So like you would see, if we would do, for example, like this, then every NFT would be overwriting the key. So the way to make it dynamic is by putting asset ID before it. Once we have done that, we need to determine what will be our value. In our case, we can store EPFS image hash as the value. So now what we will do is we will create an NFT, and we will connect an image hash connected with the ID. Then you can later query that in the blockchain and stuff like that. We can also check that out. And you could basically compose this again. So what is another thing we need to do? Like you see, currently we are going to create the NFT. We are going to connect data with it. But the NFT will basically be stuck on the smart contract, because the NFT is minted, but it isn't transferred. So to transfer it, we then need a script transfer transaction. This script transfer transaction will need again some parameters. So if we go look what we need a recipient, we need an amount, and we need an asset. So first, to determine the recipient, we can create a new variable. We say recipient. So where is the recipient located? In our case, probably the invoker will be the issuer, so he should get the NFT. So how can we get the invoker? I.color. So I from invocation, you see here in the callable, you get it passed through. So we take the color and we say that's it for the color. We don't need the string value. So now we can put that here, recipient. I guess it's with 1. Okay. So if we then look, the second value needs to be the amount. Of course, since we only have one NFT, because each NFT is unique, the amount will always be 1 in this case. And as last parameter, we do need the asset, but we need it as a byte vector or a unit. So what can we do? We can move this conversion to string to this location, and we can just use the asset ID. Since if we look, the calculate asset ID will always return a byte vector. So now we have a very, very basic setup that basically is callable with mint NFT. We then get the color, so that will be the recipient. We have like a fixed NFT name and a fixed description. We say, let's calculate the asset ID. We then put everything in our result list. So we first have the asset, then we have the string entry where we connect the IPFS hash, and then we have the script transfer. And we could already be deploying this to see if our code is working. So I created a special seed account on the already with some raise funds on it. So we sign it, we publish it, and then we can go look in the Explorer. So if we now go look in the Explorer, we see that the transaction was successful and that we have one small callable. So if we now take our DApp and we go to wavesdapp.com, we can basically look up our DApp. So now you see we have this method, we have one parameter. So let's sign in to some seed account. Let me sign in so I can try out the method. Okay, let's swap naar this account. Okay, so now I'm logged in that account. And now I can say sign in with Keeper. And now basically to connect our hash with that NFT, we say copy our unique hash, our unique IPFS hash, and we can put it in here as a first parameter, and we can select invoke. You will see that there is a pop-up to sign the transaction. We can approve it. Okay, so let's see, transaction sent. Now it's confirmed. So if we then are going to check out what we created, then we will basically see a transfer happened with one NFT. So you see the sender is the smart contract, the recipient is my invoking contract. We see we issued the NFT, obviously, with our fixed name. And we see we have a string entry with some data connected. So if we go look at the string entry, it's a bit more easy in the JSON. Then you see that we have basically our asset ID underscore IPFS connected with our hash. We can verify this, we can take the hash, we can go to here, and you will see it will load the same image. So basically, any UI will be able, or any piece of code basically will be able to query this data from the blockchain and be able to represent it. Now, obviously, you don't want to call all your NFTs the same. That would be quite annoying to recognize them. So let's add something easy as the amount of minted NFTs. So we would add something like this, and we could add here, for example, a number. Now we need to convert this number. But if you look, this would still be hard-coded. So what are we going to do? We are going to store even more data on-chain. When you have some keys that you will be reusing regularly or that are like global, you can define them here. Let's say let total minted key. That will be creating our index. Let's say how are we going to store the key on-chain? Let's just call it the same. So we will be using this as our variable to store on-chain. So what do we need also? Of course, we need to be able to check how many already are minted. So the method or the way to do that is with a get integer method. But what would happen? Let me first do the let amount minted is gelijk aan get integer. So basically you have these get calls, get integer, get string, and they will be able to pull up the data from any address that has data. In this case, we will take it from this, and we will have as key total minted key. That's very nice, but there is one big problem. The first time we will be calling this method, it basically won't be existing. And because it doesn't exist, it will return unit. But if we would want to count it up, like +1, that would already give an issue. So if we aren't sure about it, if it does exist, we can basically create a helper method that will convert non-existing to a 0. So unit will be converted to 0. So the method I usually create, I create two methods. One method is like try get integer external. That will allow us to pass an address. So we also say we want an address type and a key, comma, key. Then basically now we need to have the match code in it. So match, what does it do? It will go look for different cases. So we are now going to call the same get integer. It needs our address, it needs our key, and then we are going to define our cases. So case 1 is it finds the integer. If that's the case, we of course want to return the integer. But you already see it. There is another option. It might also be a unit type. So to make sure the code compiles and to catch the error, we will basically do underscore. So that means if it isn't an integer, anything else, we will just say return 0. So that now means that whenever we call this method, it will check in our place, does it exist? If it doesn't exist, just return 0. The second method I create is basically the method to have like the data called from your current smart contract. So I will just give one parameter, it's our key, and then we can call our first method, try get integer external, where we say this. This will basically be the address of the DApp. So this will be our first parameter. And we then say we also want to have obviously pass through the key. So why did we create this method? Because now we can just create try get integer without this extra parameter of the address that will be the same for us. So now we can say, okay, try get integer. We place it around our key. Oh. And now you see that if we go on try get integer, that we basically would be able to add 1. So now what will be happening in our first mint that we will be doing, we will be starting with nothing. So when we try to do try get integer, it will call the try get integer external method. It will pass through this and our key. We will end up in the case that we don't have anything, so we will have unit, and we say return 0. Imagine in the second case, we will end up with the case being an integer, and we will just return the value. So the first time it will return 0, and all the other times it will return what's stored in the blockchain. Now, of course, we need to move our amount minted a bit up. So now we can make our asset name dynamic. So we can say amount minted. We will be using in our name. So since this will be ever growing, every following asset name will be unique. What is also important? To store our new value. If we wouldn't be storing our new value, then like every time we would be minting our first NFT again. So we need to store all the computed values that we want to use in the future. This will be an integer entry because it will basically contain the amount of mint. So now we need to check again for our key. We defined it globally, so that makes it very easy. We can just say total minted key, and our amount is amount minted. Of course, we need to add a comma. And now you will see we store this amount. Now we will try this out once again. So we deploy it, we add the signature, we publish it. We go to our DApp. Okay, I'm still logged in. Let's say invoke. Okay, we invoke the DApp. Let's see to loop to our result. So if we now go look to the result, we see we have minted the first NFT, Dora NFT number 1. We will also see the total minted key is 1. Okay, so let's try a second one to make sure that every value is recorded properly. So we mint another one. Yes, we approve again. Okay. And we can go check that transaction also. So what do we see? Our number of NFT increased, and of course our value increased. So that means we have now like a very unique name for every NFT that we are going to mint. What do we still notice? We have this first NFT hard-coded. That's quite ugly, I would say. You could do different things with it. Personally, I'm a fan of putting some JSON in the description, so it will be easy to be parsed and you can give some additional parameters to it. So let's create a JSON. So for now, we are going to say let name. We are going to compute that later, give it as a parameter, and we will put our current hard-coded name in it. That's the first step. So now we put name back, and now we see we have a variable in our name. So now we need to think, what do we want to do with it? Like I said, I'm a fan of creating some JSON around it. So let's do that. What's very important if you are creating JSON is that you would be escaping it. So I want to call that parameter name in my JSON. I need to escape it again. Okay. Double point. Then let's see. After that, I need again a quote. That quote I need to escape. And I need a quote to end my string. So now I ended my string and I add my variable. So basically the first and the last quote are there to escape are there to escape no are there to make a string from it, and the other ones are there to make valid JSON from it. That's also why we have this backslash. Of course this won't be valid JSON, so now we still need to compute the back of it. So we want to add some string to it, we want to open our string and close it, and now we need to make sure that it's valid JSON. So we add a backslash, we add a double quote. Let me see. And then obviously we still need to have a closing curly bracket. Okay, so let us double check that we have the right escaping done. So we escape around the name. Okay. So note that we should form some valid JSON. Now let's also pass the name as a parameter to it. So let's say name. Of course, that's a type string. And okay. Now we don't need this name anymore because we are passing it through, and we will be storing it in our description of the asset. Of course, there are a lot of methods you can do it. You could also do it in some data transactions. So let's also do it that way. So we just say again the asset ID to base 58 string, and we connect there the parameter name with it, and then we store the name, and we add a comma again. So now if we are going to try it out, what do we want to see? We want to have a custom-made JSON body. We want this name to be dynamic, and we want to have an extra string entry. Of course, it should still be increasing numbers and store the IPFS hash. So let's deploy it again. Publish. Okay, so now we will need to refresh this page because, of course, our method has changed. Let's connect with Keeper again. So we say, this is our third very cool NFT. Okay, so we are going to say that. We take, again, this IPFS hash. We store it. We say invoke. We sign the transaction. Approve. Okay, we can close this again, and we go look on the blockchain. So what will we see now? A third. So the numbering still working. We see we have now a custom name stored. And if we would go look to the NFT, you see that we have added a description with name, double point, and then our name that we defined. And that way you could add some small metadata to the NFT that is very easy to see. Okay. So let me see. What I also like to do is we could, for example, extend this JSON basically. So we can copy paste all the parts between it. So we add a comma, we say okay, we paste it, and we say here, let's store the hash also in the body, and let's paste the hash. Okay, so let's deploy one more time to quickly check. It never hurts to check what you're doing, because sometimes a small change can make it from working to broken. So let's try it out. We approve again. Let's look to the transaction. Okay, we see our 4 NFTs. It's still increasing. We updated the body, and what do we see? We have now the name and the hash stored in the description of the NFT. Okay, so this is basically the basics how you can create or how you can mint NFTs on the blockchain. Let's do one last thing. We obviously want to have some kind of payment attached to it because we want to earn something from our minting service. So we will now start with checking the payment. So first, we will be getting the payment. So we say PMT, so payment. We will say if the invocation dot payments dot size. So we will see if the size of the payments is exactly 1, because if we would have too many payments, then the user send wrong invocation, or if we have no payment, then of course we don't want to process it. If that's the case, then we take I.payments and we take the first one, so at index 0. Why can we do this? Because we know there is exactly 1 payment available. If that's not the case, then we want to throw an error and we say, please double check your payments. Okay, so now we have the payment. Of course, we still need to be validating it. So how can we check if the payment is waves or not? Basically, if it is waves, the payment, its asset ID will be unit, so undefined. So we can check if is defined, and we say PMT asset ID. So we say we take the asset ID. If that's the case, then throw error, please attach only waves. And we again have the else statement. Let us see. What did I do wrong? Let me quickly check. Is defined. I see it. I made a type with 3S. Okay, so it should be 2S, obviously. So now please attach only waves. So we check already that there is a payment. We check we should only attach waves. Let's now also check that they attach at least 1 unit of waves, so like the smallest entity. So they can do, or let's make it 2, so we can clearly check that they can't add too little. So now we will go and we say if PMT.amount, so basically the amount in the payment is smaller than 2, and we will throw again an error and we say please attach at least 2 units of waves. Okay, if then else. So what's very important, because the blockchain doesn't know decimals, 2 actually means 0.1234567 So it means literally 2 of the smallest possible units in waves. If we would want 2 waves, we would basically need to add like 8 zeros. But for the demo purpose, we just put like 2, the smallest unit of waves. So now we can deploy and test this again. So let's do that a final time. Did we append? No, we didn't change anything. So if we now will invoke it, we should get an error. So it says, please double check your payments. That's correct, because we didn't add a payment. So now let's add 2 payments of the smallest unit. Okay, we will try again because now we obviously are going to pay for it. Oh, we added by accident 2 payments, so it fails again. So this time we will add 1 payment. Let's see if it complains if we add too little funds. Yes, so it asks us to attach more funds. So now let's say we are going to attach 3, and now it should be working. Let's approve it, and there we go, the TX did work. So if we now go look on the blockchain, you see there was a small amount of waves paid to the DApp, so our DApp is starting to earn some waves for it. We created our 5th NFT, so we have still the name, we have still the EPFS hash connected, and if we would go look to the NFT itself, then we basically see that this is also still fine. So let's check out how we would be querying this data on the blockchain. So imagine you are a developer and you now want to query all the data connected with this NFT. We basically say we go to our smart contract. We have a call that searches on the regex. So we take the DOP. Our match will be dot star, so that will be wildcard, and then we will be looking for our asset ID. So if we would query it, execute, and we see based on our asset ID, we find now the connected data on the blockchain. And this way you could, for example, display it in the UI, do some data calls, and then be able to display the name and the EPFS image to it. So this is a very basic DApp. So if you want to practice some more, there are some things that you basically could be doing. You could, for example, a method to blacklist some NFTs. So what could be done? So we could be blacklisting NFTs with a method. For this, you would be using a Boolean entry. What could also be added, for example, we have this tool, it could be stored in another smart contract. So then you would be calling this try get integer external with this external smart contract method. Or you could also say, I don't want to be paid in waves, and you could basically change it to be an asset ID. But this is our little DApp. So this will be our little DApp, and this is basically my workshop for today. I'm not sure if there are some questions now.
Yeah. Thank you so much, Bram, for this very useful and detailed workshop. We do actually have questions. I guess it's not complicated. So he asked, do I understand correctly that the webinars about NFT will be in the JavaScript plus Funk stack later?
So I guess he is requesting like to build some JavaScript code that connects with the DApp.
Got it. Yeah.
So
Yeah.
I guess that's I guess that's a question I can't answer. That should be discussed with Waves, I guess, to have some webinar about how to have a UI or a front end with the blockchain connected to it.
Got it. And another question is that Waves, basically he asked if Wave is a dApp specifically for maintaining NFT, which answer is no. Wave is actually a layer 1 blockchain. And he will also want to know some few advantage of Waves and like why should he switch from a JavaScript and Tonkley to Waves?
Well, basically, Waves is very easy to understand. The right language is like non-Turing complete, so you can't make a lot of bad errors with it. Of course, you need to check some stuff, but it's very easy to learn. We have also this Waves docs, docs.waves.tech, and basically you can find all the methods that you would need to start writing your own dApps. You can see here, advanced write programming language. Another advantage of the Waves blockchain compared to, for example, Solidity is the fees on Waves are very cheap. And of course, you have a very active community that can help you support with the development and stuff like that.
Yep. Awesome. Yeah, I guess that's all of the questions that we have today. Cool.
Okay.
Yeah. Thank you, Bram, again for joining us and provide this brilliant workshop to our global developer communities. It's been super helpful. And in the future, I think I made a mistake at the beginning because the Wave Hackathon actually got extended to late of the March this year. So basically, we have like one extra month to for the Waves Hackathon. So if you are interested in building something on Waves blockchain, please feel free to join us through the DoraHacks platform. You can submit your project to participating and competing for the Waves Hackathon. And if you win in the end, we'll have chance to winning some very good prizes and some support resources connections from both DoraHacks and Waves Labs. So yeah, don't hesitate to join us. Cool. I guess that's it for today. If you haven't followed DoraHacks through our social channels, please feel free to do that as well, because we will host a series of the events like today's. So if you don't want to miss out, please do that. Yeah, appreciate everyone to join us today for all the participating and engagement. Thank you guys so much, and hope you guys have a great one. Yep. Thanks again, Brad.
It was
Cheers.
a pleasure.
Yeah.